Hi, I'm Peter Cooper, and I'm going to show you lots of quick-fire Ruby trick shots. Why the picture of the boxcar? I was originally going to do this as a collection of stunts. That graphic worked better for that, but I like the graphic, so I'm going to keep it. Now, trick shots are small Ruby tricks or techniques that I've seen or shared and experienced in various ways, and that very experienced Rubyists that I know have said, I didn't know that, or wow, that was kind of cool. So if an experienced Rubyist has actually said that to a technique, I keep it, note it down, and I think it's worth saving to share. So I've got just over 100 of them now, and I'm going to share about 20 to 25 in this video. But the plan is for the full collection to be put into an ebook and online, into regular HTML pages, with some explanatory text that goes into why this occurs. How am I going to do this? Do you think this is a big money-making scheme? Well, no, it's actually going to be free. But part of the reason for doing this is that I want to test the concept of cheap, fun, programming-related books that you can just sit and read anywhere, on the couch, the bus, whatever, on the Kindle, as I haven't seen any yet and I think it could work. So it will cost a few dollars on the Kindle, but that will be it. But it's all going to be on the web too, so you'll get that bit for free, or you can just watch this video and enjoy this. So I need to give you some warnings first. First, I'm using MRI Ruby 1.9.3. If you're using JRuby, Rubinius, something else, some of the tricks may not work, perhaps on 1.8 even. Most will, because they're related to Ruby's core syntax. Secondly, not every trick should be used in production code. And what I mean by this is not that they're necessarily dangerous, but that they're perhaps a little bit too clever sometimes. And if you use them in all of your code examples everywhere, people might, they might not be very cool with that. So most are fine, and some may even give you a wow, I must use this moment. And I've had people come up to me after a talk that I gave like this, people saying, I'm going to use that technique. But some will just make your code look bad and, air quotes, too clever. So be careful. So before we get to the tricks, if you like what you see, there should be a box further down on this page, unless you're on YouTube, unfortunately, with an email sign up so you can get a few emails about the release of the book. So there's not going to be any spam, anything like that, and because my mail provider, MailChimp, they would massacre me if I spammed you, so you're safe. And every email gets has immediate unsubscribe links at the bottom too, so you can immediately get out of it if you don't like it for whatever reason. So without further ado, on to the trick shots. Getting a random number in Ruby is quite easy. We use the rand method here, very simple. Rand 10, that will give us a number between 0 and 9. But what if we want to get something from a range? Well, sometimes you might have a high number you want to get, a low number, and then you'll do some kind of magic where you do high minus the low plus the low, all that type of thing. Well, in Ruby 1.9.3, we no longer need to do this. We can use rand, and we can literally use a range in there. And that will even work with the non-inclusive ranges. Now, if you're on 1.9.2, that's not going to work. But there is a kind of a workaround for it. You can use random.new.rand. I know, and that will work in exactly the same way on 1.9.2. So let's hope this becomes a popular technique soon, because it really does save a little bit of thought process and time. Most Rubyists frequently have a need to get a nicer representation of their objects, dig into them for debugging, all that type of thing, and you might be used to using P, so like that, or PP, which is a prettier version. But Awesome Print is an even prettier version. Let me just show you. So what I'm going to do is require AP. I'll put in that same array. You can see we have the index numbers and it's coloured, all that type of thing. Now, if I go to some code here, we have an array of hashes, and there's also some kind of internal embedded arrays in there as well. I'm doing exactly the same thing as before. If I head back to the prompt, however, and I actually run this code, you get to see it's all coloured, it's all indented, all that type of thing. So really, really cool. I think it's best, well, let me just tell you that the name of the gem is Awesome Print. It's not just AP, but you should Google awesome_print, go to the GitHub page and learn more about it, because I've just shown you the very basics. It even integrates with Active Record. There's a way to make it be the default output form in IRB or Pry. Lots of stuff to learn. So excellent work there from Michael Dvorkin, and definitely one of my recommended libraries. This one really is curious. Let's say we want to concatenate one string to another. Well, some people may consider this to be concatenation, but there is also this. That's nice and simple. The good thing about using concat is it will actually return exactly the same object. It takes the ABC string and then puts DEF into it, but it's exactly the same object ID, everything. But there's another way of doing this. Try this. Or Now, what's going on here? You might not see any methods or anything going on. Just merely having spaces in between multiple strings gets us them all concatenated together. And if I come over to this, you may think, okay, what's happening? Is it using plus or is it using concat behind the scenes to do all of this? The answer is no. If we run this code, and what I've done here is I've overridden what plus and concat do in the string class. Could have done this a bit more tidy, but you know, nice and quick and scrappy. If I run this, we get the exclamation marks for using the plus method, but we still get ABC back by using this technique. So it circumvents all of that. It's a more direct way of concatenating strings together. Interesting curiosity. Let's say you want to call a function in a system library or some other library that's been compiled. Well, you can do so out of the box with Ruby 1.9 using something called fiddle, which is an abstraction for the FFI, which is the foreign function interface. So all we do is we bring fiddle into play, we open up the libc, which is the C standard library. This is the file name that it has on Mac OS X. And then we create this, basically the function object that points into the string length that's part of the C. And we tell it we're going to pass in a void pointer and we expect back an integer. We make the call on this little string and we would get back the number 5. But you may be more familiar with using a library called FFI directly, and we can do that, and you might even prefer this API. You see, it all works in a very similar way, but just has a different way of calling and setting up the function handler. Well, the difference is that for FFI you have to do a gem install FFI to get hold of it, whereas fiddle is part of the standard library in Ruby. But is there a better use for all of this than just getting the length of a string? Because we can already do that in Ruby anyway. Well, the reason that I got into this was that a friend of mine was trying to re-implement the system crypt function, so that's what I'm referring to here. And I said, why don't we just do it this way? So this made it really nice and simple, nice and quick, and if I run this, you get to see the encrypted output. So I thought I'd let you know about that, but you may want to use FFI instead. This is the simplest way to check whether one string contains another as a substring. So I've got my string here, x equals this is a test, and the most common way that I see people do this is they would do like a regular expression and put that together that way. Well, it's actually a lot simpler than that. Just do that, because if the string doesn't exist inside there, so we'll pick that, then we get nil back. So you can use this even in a conditional, very simple. Useless trick alert. You may know there are many ways to put literal strings into Ruby. So for example, you can do this type of thing, but then there's also these approaches using the %sign, which can be very handy. And you can use a lot of different things as delimiters. There are a number of special characters that you can use. Well, believe it or not, you can actually use spaces. So try this on for size. That actually works. Evil. Don't use it, but it's a trick. Sadly, this isn't the time to give you an introduction to exactly what modules are, but hopefully you're familiar with this type of construction where we have two modules, foo and foo2, which both have a method inside, and we include those into a class, and then we try and use that method. What's happening here? Well, when we include foo, that goes onto the ancestor chain. When we go foo2, that actually ends up underneath foo on the ancestor chain, so its version of bar will end up being called first. Well, what happens if we want to include multiple modules in a different way? You can actually put them on the same line. So look at this line here, for example. I've done include A, B, C. Well, what happens? Well, what I've done is I've gone in, I've used the included method on the modules just to see when they get included. So what I'm going to do is I'm going to run that, and you'll see it goes C, B, A. So that's the order that they're being brought into play. So very interesting, but you may get confused by the ordering of this here. But a lot of people didn't seem to realise when someone posted this on Twitter that you can actually do this with include, so you may find it useful. String interpolation in Ruby is very simple. We have two strings here, one on an instance variable called Maestra, one on a local variable called Maestra. Different strings, however. Now, you may be familiar with, if I want to print out the value of the string, I could put in some rubbish here. I can use £, curly braces, and then I can include whatever I like in here, including any Ruby code, in fact. Interpolation. Well, if you are using instance variables, or actually any variable that has a sigil at the start, so that's the @ symbol or the $ symbol for doing global instance and class variables, you actually don't need the curly braces. You can just do it like this, and that works straight out the box. If you want to check that a Ruby source code file is syntactically valid, you can do so directly from the command prompt. Just use ruby-c and then your file name, and it will tell you whether the syntax is okay or whether it's not. Now, this won't tell you if there's going to be an exception as soon as you run the code. It may pass okay, you may put method names in that don't even exist, but it's all about the syntax. I'd just like to thank Nick Quaranto for letting me know about this tip. In the last trick, we merely checked whether a Ruby source file had valid syntax or not. Well, we can go a step further with Ripper that comes with 1.9, it's in the standard library. What we can do is we can do syntax analysis. We can see how Ruby has interpreted a piece of code. What does it actually mean? And a piece of code that's actually quite interesting, it's quite confusing, is what does puts curly braces dot class put out? Well, it doesn't tell you that it's a hash. There's actually some more complexities to this. So all you do is you just require Ripper. I'm using awesome print, as we mentioned before, because the output from Ripper is quite complex, very complex, these syntax trees. And then I use sexp. So what that would do is it will show us the syntax tree in an S expression. So I'm going to not run this from here. I'll run this from the command prompt. Run Ruby Ripper. And this is quite complex. You do get used to reading these eventually. So you get to learn that, you get to look at calls and then where the method name is and all this type of stuff, which is up here. These are quite tricky to read, but once you get the hang of it, you'll eventually start to go through and you'll realize what each of the different parts means and why a certain output occurs. And in this case, when we're doing puts curly braces dot class, that curly brace is actually representing a code block that's being passed to puts, and then class is being called on the output of puts, or the result of puts even, which is nil. Did you know that you can chain ifs together? Some people didn't, so that's why I've included it as a trick. Personally, I don't think it's incredibly useful, but just to give you a very quick demonstration, like so, there you go. Quoting from O'Reilly's The Ruby Programming Language, the next statement causes a loop or iterator to end the current iteration and begin the next. And we can see that in play here. We go from 10 up to 20 using the up to method. We use next, and that will skip all of the even numbers, so we'll only print the odd ones, as you can see here, 11, 13, and so on. If we move to map, slightly different example, but again, we have a code block. Now, something that quote from the book didn't take into account is that this code block, behind the scenes, it's treated as a proc block. You may be familiar with lambdas. Lambdas are just a slightly different flavor of proc block. They have a slightly different behavior. Now, from a lambda, what you can do is you can use the return statement like you would from a method. But in a proc block, things are slightly different. If we use return here, and I will try that, we get unexpected return. And that's because in proc blocks, the scope of things like return, it will come out to the outer scope. It's not actually referring to the scope of the block itself. Now, hopefully you know what this will do. We're going to take our array and we're going to map that array to another one using the logic that's inside the block. So what happens behind the scenes is that the map method will call this proc block each time for each element and then set the element to whatever the value is that's returned. So 2, 4, 6, 8 in this case. Well, what if for some reason I want to just randomly, let's say, set the value to something else? So I'll write this perhaps as I might logically think I could do it. So let's say I want to return 10 if random 5 is equal to 0, for example. Will that work? Well, no, it won't. It will come up with that unexpected return error again. But in the scope of proc blocks, next is actually like its form of doing a return. So this will return 10 to map, and then map can put 10 into the array, and off we go. And I'll actually reduce this number just to increase the odds of us actually seeing something occur. And I run this, and you see, so it would have been 2, 4, 6, 8, but randomly ended up putting a 10 in here. And that's all thanks to next. Just for your future enjoyment, I have a video on YouTube called An Introduction to Procs, Lambdas and Closures in Ruby. It's about half an hour long, and it digs into a lot more detail about this type of thing. I thought this was pretty simple, but I've actually seen a few advanced Rubyists get called out by this one and say, wow, that's a really, really cool trick. So I want to show this off. It's called array zip. It's a method on the array class. So I've taken two arrays here, one of names, one of ages, and I just do names.zip ages, and it zips them together. So you end up with an array of arrays where each element has the name and the age of each respective index kind of zipped together as it will, if you will. Now, we can do something really cool with that. We can use the wonderful hash square brackets method to form a hash from one of those zipped arrays. So what happens in this case, we actually end up with Fred, 38, JS, 47, and so on in a hash. That can actually be quite useful. But there is a little bit more to zip than this. You don't just have to zip one thing to another. If you look at this example here, I've added something else called locations, and you can actually zip the names to the ages and the locations. So we end up with a slightly different arrangement here. But then zip can also take a block, and this pretty much works a bit like putting each on the end, essentially. Just a little bit of a shortcut, and gets you access to each zipped subarray, as it were. And then this just shows you what happens there. A short and sweet one, this. What if you want an array of the numbers of, say, 10 through 20? Bam, there you go, done. How exactly is this working? Well, you can explode things into arrays in pretty much with any object that supports to A. So to convert something into an array, kind of implicitly behind the scenes. So for example, what I could have is I could literally have just a number 10 floating around. Bam, I can get it into an array. But then C may be an array. Well, bam, I can still get it into an array. So this can be handy in, say, methods where you're being passed something, you don't know if it's going to be an array or some kind of object, just a singular object, and you want to loop over it. Well, you can just force it into an array in this way, and it works for everything. There is actually a shortcut to doing this. Well, I say shortcut, it takes longer to type, but you may prefer the way this syntax works, like so, and again like so. Be careful with hashes, though. They don't behave in quite the same way. Be careful. JSON, or JSON as it's more commonly known, JavaScript Object Notation. It's a very handy format for passing data around and even putting output from Ruby. And you can do it very easily now because JSON comes in the standard library. So what you do is just require JSON. You want to print stuff out in kind of like a P style form, like what I've got here. I've got an array of hashes, and I can use P to print that out, print out the Ruby object kind of notation there of it. What if I want to do it as JSON? I can just use J now that I've loaded the JSON library up. Works in exactly the same way, and then this works, could be copied, pasted into JavaScript, let's say. There is also another extra part, which is JJ, and all that does is it kind of is the equivalent of PP, really. It's more like a pretty printing of that. Let's say you want to dynamically get hold of the name of the method that you're currently in. You can do that with __ method, __, and the equivalent with callee in as well. So you can see that in play here. We'll call my method, we're printing both of those out, and we get a symbol with my _ method inside. You think, why is this useful? If I'm in my method, I know I'm in my method. Well, if you're doing metaprogramming, there may be some reason why you don't actually know exactly where you are at that point. So a slightly more complex example here, a bit convoluted, but we're kind of dynamically generating methods called A, B, and C within this class. And then we call A, B, and C once they've been generated using define method. And because we got the __ method thing in here, and again that could be callee, if we run that, we then get the symbols for A, B, and C back. So it's a way for a method to check what its current name is. I might not even need to say much for this one. This is just a case of if you're doing method chaining, you don't need to cram it all onto one gigantic line or split things up into multiple different kind of expressions. You can still do method chaining and split them across multiple lines. You can see that in action here. I know lots of people, me included, use IRB as a kind of glorified calculator from time to time. Well, one thing that can come in very handy there is knowing that underscore as a variable refers to the last returned value that occurred in IRB. So for example, I'll give you a very, very quick example, a times 2 underscore will now continue to equals 20. And we can keep using that. And again, now underscore will equal 400. So you can use that to build calculations up upon one another if you don't necessarily want to use variable names. 2 tips in one here. Did you know that you can represent binary numbers in Ruby using 0b and then your binary representation of a number? Well, you do now. But what you can do in Ruby, and you don't have to do this on binary numbers because they just turn into normal fixed numbers at the end of the day, is you can check which bits are set within a number. So in this case, we'll keep it very simple so that we'll do that. It's number 170. It's just literally 01, 01, 01, so on. Well, let's say we want to check whether the the first bit is set or not. It's not. And remember the indexing on arrays, just be very careful there. This isn't actually an array. It looks like array indexing, but we're actually checking whether a bit is set or not. So this 0 is checking, is that set? And then the 1 is checking, is that set? 2 would be there, 3 would be there, 4 would be there, and so on and so forth. Now, there's another way of doing this. This may be the more kind of like traditional way of doing it, is you could also do C and then do a binary AND with 1 shifted to the right number of places there. Here you wouldn't be checking for whether it's 1 or 0 though, but just checking whether anything that's non-zero comes back. It is possible for method parameters to use other method parameters in their defaults. So here we have A, but then we have B equals A, meaning that if B, the second parameter, doesn't come through, the second argument isn't passed, then that will default to whatever A was. So here, when we pass in just 1, A and B both become 1, 1, 2, we get A equals 1 and B equals 2. Proc objects have a source location method. This will return an array with the file name of the file where that proc object is defined, and then the second element is the line number upon which it's defined. So here, it's very simple. If I run that, you get the file name each time, and then the line number on which it's defined. I actually use this to quite good effect in a testing library I built called TestRocket, where you put assertions in different proc objects. But this also works on methods as well. So if we grab hold of, we'll use AwesomePrint, which I mentioned earlier in the video, and then I will grab that AP method that's been defined by it, and then I'll ask it for its source location. So if I run that, we see this added on now way down deep in my file system on line 14 is where it's defined. So this can be very useful for debugging, but it's also for if you're building tools that are working with Ruby code and you want to dig into things. I believe the pry, which is like an alternative thing to IRB, I believe that uses it to pull out the source code for things dynamically on the fly. I also saw someone use this technique in Rails, for example, where you're checking to see what did active support stamp all over a monkey patch. And the reason for that is that if you call source location on something that's an internal Ruby method that hasn't been messed with, it will come back and it will be nil. But if you do it on something that has been messed with, and I must admit this isn't the best demonstration, but if you call it on something else, so I take where it's added an extra method to the string class, tablize, and I run source location, then it will tell us somewhere way down in the file system where active support lives. So it can be a way of checking for that as well. Let's say you want to prepend one string to another. I've got world here. Well, you could always do something along these lines. And again, we put hello to the beginning there. Well, that's not very efficient because what's happening is it's creating a new string object and things have to be garbage collected and so on and so forth. So another efficient way of doing this, and this is one that you maybe actually be familiar with, is we'll say insert a position 0. We'll insert the hello that way. That returns the same object that time, much more efficient. But in Ruby 1.9.3, there is actually a prepend method that does exactly the same thing. See anything unusual about this source code here? Well, it's this underscore underscore end underscore underscore. And what that does is it tells Ruby, don't go beyond this point, treat everything beyond this point as data essentially. So if I run this, we only ever get hello world because it will never actually move on past that end point here. But why is this useful? Well, Ruby has this concept where it will create something that's a file object that points to the current file in data when you have this end tag present. And what we can do is let's do puts data.read. We run that, and then we actually get that text that was down the bottom is now coming back. So we're reading it like it's a file. It is a file, source code file, and we get that data out. So you could store data that's associated with a small Ruby script in this way underneath the file. There's one small quirk to this, though, that I know some people weren't familiar with. All that's happening is that data is pointing to the current file, but its seek position is placed literally just after the end. What this means is you can actually rewind the seek position, and you could do print out data.read. I'll change it to a puts because it looks nicer. And if I run that, you'll now see we actually get the entire source code file come out. So this can be a way of reading the current file in without using the underscore file route. Last but not least, I'm going to show you a few simple regular expression techniques. These are going to be very simple. I'm actually doing a full-length kind of masterclass style video of regular expressions in Ruby, digging into optimizations and literally start to finish regular expressions. But I'm just going to focus on a few things here. So I've got my string, Fred Flintstone, superhero, and what I'm going to do is I'm going to start very, very simple. Let's say, I want to make the first match of, a group of one or more word characters. Well, I can do that. That gets me my Fred. Very simple. You're probably familiar with this type of thing. But, I can extend this a little bit more. And that gets me my Fred Flintstone. But then because I've used parentheses here to kind of, get some matches, I can then ask it for the first match. I can ask it for the second match. Again, that's pretty cool, pretty straightforward. Where it starts getting interesting is when you want to give names to these. So what you can actually do in here is I'm going to call the first one A and the second one B. They don't have to be names as simple as that. It could be like F name and L name or something along those lines. But we'll keep with A and B, very simple. Well, now if you put a symbol in here, that symbol will come up with the match instead. And you don't even need to do all of that. You could actually just do that, and then you can still get access to this stuff using a special variable, which is called $tilde, and this gives you access to the same thing. I'm not a big fan of this, but if you're doing something really scrappy, could be useful. And then, last but not least, this little trick, I showed this off at a talk, and I was a little bit hesitant about whether this is a good idea or not, but a guy came up to me afterwards, and he says, I'm going to be using this in my scripts, this is really useful, thanks for letting me know, so I have to include it. It's a little funny kind of Ruby quirk. If you take the regular expression, and it has to be literal, on the line, and at the start of the line, use the operator to do the match against the string. You think, okay, what's happening there? Well, it's just telling me that there was a match, on the very first character, which that's pretty obvious. But what it's done is it's set, and it's created the local variables of A and B containing that information inside. So you may find that useful. Nice trick. So that's it, folks. Hope you learnt a few interesting things from this. Whether you're interested in the book or not, just use this video on its own if you like. But otherwise, sign up below. If you're on YouTube, you might have to kind of look at the URL and go to that URL that's on the page. But if you're on the page that hopefully I've sent to you, then you can sign up below. You won't get any spam or anything like that. I mentioned that at the start of the video. Sign up. You'll learn about that when the Kindle book comes out, and also when I put these things on the web page as well. So, yeah, just sign up. That'll all be great fun. But otherwise, yeah, thanks for watching. I hope you enjoyed some of the tricks. And remember, I've got about 4 or 5 times more than this, and I want to structure them properly, go into a little bit more explanation about them, so, it'll be kind of fun. But just remember the warnings that I gave earlier. You don't necessarily want to cram all of these into your production code. So thanks for watching. I'll talk to you soon.